Hi guys. So one of the drawbacks that most people who love to work with Python are actually or happen to be its inability to not have like a strict type system. And of course, there are a lot of inbuilt-in libraries like the typing package that could, for example, help you to maybe implement something for yourself. But in the end, this can actually pose a problem whereby you actually get to not be able to catch all the possible errors that you could have caught if your system was or if you're working with like a strongly typed language. And of course, I also understand this is one of the strengths of Python, whereby you have the option to actually prototype real quick and maybe do something pretty quickly. But also, again, it also brings it into picture the possibility of you also making quick errors. So, what I want to do today is maybe talk to you about this. So, one thing that people do to get around this, of course, is try to use, like, say, third-party libraries to try to check or guard um, whatever it is they are doing. Let's say they are building a server in Django or whatever, and they expose some APIs, and they want to somehow validate this payload. So there are a lot of third-party libraries out there. Like, I think the most popular one would be the most popular one should be Pydantic. But there are also ones like Cerberus, and I'm also going to leave the links in the chat in case you would want to check them out. But what I would like to do today, of course, is to maybe show you how we can do something of our own real quick. We don't have to install any third-party libraries, and we also get to tailor the library the way we want it to behave, the way we want it, and of course, maybe also give us some custom-made error messages should in case something go wrong. So just imagine we have I'm gonna make it as simple as possible. So let's say I have here a class and I can call this payload. So we have a class called payload. And maybe what I can actually do is to um bring in, so I can go from data common classes imports data class, and then I can actually annotate my class as data class. And now I can actually give you some attributes. I can say maybe name is going to be a string. I'm going to have email, it's going to be a string, and maybe phone number. Maybe I'll make this a number. Is it number? I think it's just int. Let's just make it as int, and maybe age. Let's make age an int. And I think that should do it. Score, whatever. This could be a float. So this is one way we can actually, let's say, for example, if we want to go like the OOP route and want to define a class to represent our method, and now we can actually probably go ahead and implement some methods for our class. So like you would in regular OOP programming. So say something like, I don't know, get name, and we'll pass self, and we simply return self dot name, something like this, pretty straightforward. And but the thing is, if we come here, so if I say if how is it again, is it main or if it's name, I can't remember, is it name is equal to main, is it um I don't remember, whatever, but I'm just gonna go ahead and maybe define a function here. I can call this main. Okay, and then in my main method, I might like to instantiate a payload. So I can say payload, if I can type. So payload would be of type payload. And now, of course, I need to provide all these attributes, but the sad thing is that if I don't provide anything, this is still fine. I can actually come down here and say print payload.getName, for example, and I can come down here and say main and say Python. And again, now at runtime, actually gets this error that's missing five positional arguments. Of course, in case you're not familiar with the other classes, having something like this is also like when I had like a constructor method here, like init. So adding an init method, that's basically what I have up there. And now I can pass all of this in here, say, I don't know, maybe name and the rest. And then in here, I can now assign them and say self dot name equal to name, something like this. Of course, I need to pass self first. So, but without us wanting to do all of this, that's why we're using this annotation up here. So, but here you can already see that we don't even get to we don't even figure out that there is a problem here that we didn't provide these optional arguments. This mandatory, they are actually not optional, and now the whole thing falls apart. Okay, so but what I would like us to do now is to implement um our own method, more or less. It's going to help us to actually validate this payload to make it a lot easier for us. So what I can simply do is up here, I'm going to create my own class. I'm going to call this base model. I think this is also how it is called if you're working with Pydantic. I think it's also they also call this base model. So I'm going to create some static classes. I'm not going to be able to do everything in this tutorial because I want it to be short. But again, of course, you have the option of going ahead and doing the rest yourself. Okay, so I'm going to create a class method, and the point is that I want to be able to invoke this method without actually instantiating this class. That's really the point. So I want to have one called from dict. So I want to be able to actually maybe log what I have as a dictionary. Um, and the one is, of course, to be part of the object, so that in the end, if any, for example, class should inherit this base model, then I would have this from dict, and I can always visualize this object as a dictionary. So again, I provide itself, and here I'm gonna use like I told you from the typing package provided with Python, I'm gonna use type. I'm just gonna go ahead and import a bunch of things. So I'll bring in type. So let's say, oh come on, from typing, what am I doing? Import type. Maybe I don't need this for now. I need any. I need dict. I need tuple. I need type var. I'm just gonna get as many of them, and then we see the ones we don't need. So I need get args. I need get type hints, and maybe also get origin, maybe union, optional. I don't know, but there are a bunch of helper methods and classes in here that can actually help to make our lives a lot easier. Okay, so I'm going to make this class, of course, generic because I don't want to tie this to a given type. So the type is going to be of type T. And of course, we don't know what type what T is actually, so we have to define that. So, but again, apart from this, I'm going to the what arguments that this should be expecting would of course be an object. We should be a dictionary, and I also want to type this to the letter. So I'm not going to expect a dictionary. The keys are going to be strings, and the values are going to be anything. So that's how I'm going to leave it for now, and this should be able to return a type T. I'm just going to make this pass for now. And now up here, I need to define what T is. So I have to define T, and I say T is going to be common type var, and I provide some additional information. So I'm going to give it a name, and I'm going to call it exactly what it is, T. And then I add some bound. So bound here is, of course, I'm going to pass my base model. There are lots more arguments we can actually pass in here, but this is more than enough for me right now. Okay, so what I would like to do here is, like we said, this is not going to be, this is supposed to be generic, so we don't want to stipulate. So this T here can now actually be of type payload or whatever classes or whatever that we have defined in our program that will be inheriting from this. So now what I would like to do is to get all type hints from the object itself. So I can say field types. So field types is going to be, I'm going to call this helper function called get type hints, and I pass self. And now I instantiate an empty quarks. It's going to be, of course, an empty dictionary, and I'm going to populate this in a bit. So now I'm going to loop through all the names and the types from my field type. So I can say field for all the field name. and field type. I'm gonna have this has to be singular in field types dot items. I'm gonna loop through everything within our items. And now what I would like to do is to of course be able to populate what we have up there, which happens to be our quarks. So I can say let me say value. I'll need to get the object itself, need to get the item from based on its key. So I can say object.get, and in here I pass the field name, and now I have the value. And now what I can do is to do some checks. So maybe I'll add a comment here to make it easier. So here I would like to come on. I would like to check if the field is a nested base model type. So in case we have multiple inheritance, so I would use the is instance function. And then here I would like to pass the field type, and of course pass a type. So if this is an instance, and if it's a subclass, for example, we are again I pass my field type and the base model. So when this is the case, and of course I need to check that the value is not none. I really like how simple Python is. I can actually almost write sentences. But anyways, if this is the case, now I need to populate my dictionary. So my quarks for each of these fields, come on, for each of these field name, the value will become, of course, the value we provided. If we have this loop, but anyways, when that's not the case, we simply do this the straightforward way. Um, Sorry, I think this should not be. No, I think what I have to do here is I go through the field type, and again I call this method again and pass the value. And now I can now loop through. I say field name. So field name will now be value. And the point, of course, is that in this case, when we have multiple inheritances or nested inheritance, as I've written here, the point is that we will now call this function, which is also this one here, recursively until we get to the bottom of it. In the end, this is where our code would always end. And I don't need this pass anymore, so I need to return something. And now, of course, I use myself, and now I just dump the dictionary that we just got. Okay, so pretty straightforward. If we want to have a way of getting the content of our object as a dictionary, we simply have this handy method here. And so what I can actually now do is to come over here and make our class inherit our base model. And now what it means is that I can actually, maybe I'm gonna keep this pretty simple. So I'm just gonna pass a name and email because I don't want to type so much. So now I say name, I say Tony, email, and I say Tony at gmail.com. I don't know, something like this. And now I can now also print payload.fromDict. And now, of course, I need to provide a dictionary again, which is going to be something like this, name, like we did before, name. So name would be some name, I don't know, and email, some email, something like this. What am I doing? Some email like this. And now what we can do is when we print this, of course, we should be able to get some like this. So the interesting thing, of course, is now we have a handy method that we can, or we need to do now, for example, is to create any object, whatever, doesn't really matter. So if we add a new one here now, for example, like we had before, phone number, and then we'll make this, I don't know, like int, and we come down in here. Of course, the one up there is going to complain, but we'll fix it in a bit. Phone number, and we add a bunch of things. Come on, I'm just going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And again, I'm going to do exactly the same here. So phone number, of course, I say 1, 2, 3, 4, 5, something like this. And of course, now we should also have this in here. So that's really the very simple, handy way. So now let's get down to business actually. What I would now like to do, of course, is to find a way to validate what we have. Okay, so I'm going to come down here again, create a static method. So again, I'm going to use my class method again because I would like to access this without instantiating the class itself. Okay, so now I come down here and define a new method. I'm just going to call this validate. Again, this is us making reference to self. So type is going to again be of type T, because we want this to be as generic as possible. So now here I'm expected to pass a JSON object. And for now, I'm going to again keep this as simple as possible. It's going to be a dictionary with keys of string and values of any type. And it should be able to return, I like to return a tuple actually. So that way I can return a boolean if everything went well, and of course a type T in the end. Okay, so what we want to do here is pretty straightforward. I want to be able to, again, I'm probably not going to be able to handle all the possible scenarios, and maybe I'll show you a simple example of really what I'm going for here. So in this case, we have a name, for example, which is a string. I can also maybe decide to make this optional. Okay, and now this name can actually be a string or none, as you can also see up there. And here, phone number, I can actually make this a union. So a union is gonna be a union between ints and floats. So phone number can actually be an int or float, something like this. So I want to be able to give, of course, my users or our users in this case the option to do whatever it is they want to do, and still be able to handle. We should still be able to handle those scenarios and be able to validate objects for them more or less. So let's proceed. I'm gonna create an argument here, and I'm gonna call this validation error is going to be of type bool. So I'm going to set it to false first. So the point is that I want to have a way to know at each point when we have errors and when we do, and then decide what I want to do. Again, so I'm going to do like I did before. So get type hint, and I pass like self. And now I have to do some checks. So what I would like to do now, of course, is to the first thing I would probably like to do here is to first see, for example, that if you provide a dictionary or an object, I will try to validate it if it has a key that is not within, sorry, if it has a key that is not within the object defined above, we should be able to error out here. Okay, so I'm going to do this with a really simple straightforward. I'm going to use set to look at the keys. So JSON obj, so I'm going to look at the keys. Come on, keys. I'm going to use set to compare those keys. So one from the objects you provided, and the second will be from the field types of the object itself. So in this case, you can think of it as a class. So I can say field types, and I look at the keys. And so if this is not the case, what I would want to do here is now to actually find those keys that are not in the provided um, definition for the class. So I'm going to probably call them extras. So I'm going to use list comprehension. And what I would like to do here is loop through all the values and check find the odd ones out. So I'm going to call it value. And I'll loop through my JSON objects, and of course go through the keys. And my condition will of course be if this value is not in field types dot keys. Pretty straightforward. Field types dot keys. Come on, help me. If value 20 is not that it's not a sentence. Field types dot keys, and I have those extras. And now what I can simply do is maybe provide a statement to the user, and I say maybe the following keys, or maybe I say the following provided keys are not recognized, something like that. and I can say maybe additional, I can say keys, and I can provide those extras. And of course, I can use string formatting here. And when I this point, I would like to terminate the validation. So if you provide any key that I don't know about, I'm going to tell you. And what that means now is I can actually, again, we have a payload in here. Actually, name this payload as well. So, but I'm gonna maybe I would get back to this later. I can call this payload V2, so we can just keep working with this one. And now what I can actually do is actually this is wrong. The return type is wrong. My bad. So this should have been I will return a false for the tuple, and for the type I'm gonna probably return none. That's totally fine. Okay, so now what I can actually do down here is I can say maybe um I don't know, payload, P for payload, and let me see, boolean comes first, and I can say is valid, and P, and then it's gonna come from something like this. Let me copy this, and now I can say payload dot validate, and then I just dump this in. And now what I would like to do is print is valid and P itself. So now we can quickly check this out to see what we have so far. So Python main.py, and we seem to have some error, cannot unpack non-iterable. So let me see, validate. So maybe here, of course, nothing is being returned. So here I can simply return true. So this is valid, and I can now use our from dict function, the one we wrote earlier, and then I can simply pass the JSON object like this. So now let's try this one more time. And now, of course, this is true. So to validate what we've done so far, what I can actually do is to maybe, I don't know, come down here and add another field, maybe age, int. And now let's see. And we should get some error. Of course, this is also something different. I can actually get rid of this part right now, so it doesn't confuse us, so we know what we're doing. So I can get rid of this part and focus on this. Okay, now we get what's happened. Yeah, of course, I need to add additional field here. I can call this maybe age, give it some number, and actually maybe remove it here, just to mean that we are not expecting that additional field. And now we should get something like this, that the following provided keys are not recognized, and now we only have age for now. So that's, of course, one way to already start the validation process. But for now, maybe I add a comment up here to make it more understandable. So here I can say validate that all provided keys are expected, something like this. Okay, and now what we can now do is to actually try to do the actual validation. So now I would like to do is to loop through all the field types. So again, like we did before, so I need the field name and the field type, and we're going to loop through the items in field types. So field types dot items, and this is actually where the validation starts. So I would try to add comments along the way as we, of course, do this. So now what I can also quickly do is to know if a given key, for example, is missing, we can also maybe put I don't know, like some output here to let the user understand what's actually happening. So I can say if a given field name is not in the JSON object that was provided to us. Now I can just print a message to the user and maybe say something like, is it going to be a formatted string? I can say something like validation failed, and I say missing key, and I can simply provide the field name. So this is what's missing. And I think that's already good enough. And at this point, I'm going to set my validation error to true. And sorry. And of course, I would like to continue. So after, I would like to look through all of the all of our values. I don't want to just terminate. I want to be able to print out all the missing keys in the end. So that's why I'm continuing at this point. Okay, so what I will now do is, but if that's the case, if this is found, sorry, I would like to get that value going by the field name. So I would also like to get the origin. So what did I do? I say origin. Origin is going to come from this handy function called get origin, and I provide the field type. And I would also like to get the args. So this is also going to come from the handy function get args, and I provide the field type. And now the validation actually just starts. So the first thing I would like to do would be to maybe look at the subscripted generic. So I can say something like if origin is not none, if this is the case, and now we can start our validation. So the first thing I might want to do is to check if the type is a dictionary. So I can say if the origin is a dict. So if it's a dictionary, now I like to get the args. So I can give them some names. I can call this key type, and I call this value type. And this is going to come from our args. And now I can just simply check the instance. So I can say something like if it is not instance, and I would like to look at the value and dict, so it has to be an instance of a dictionary. So, but if that's not the case, I would like to again give the user some meaningful output. Again, we're going to provide like a formatted string, and then I can simply say again validation failed, but I need to tell them why. And I can say for key, I provide the given key field name, and now I can say provide additional information like expected a dict got, and here I can provide the type of what was passed, so simply passing the type of value. And whenever I encounter an error, I'm going to set my validation error to true. But if that's not the case, I would like to look through all the keys of the dictionary. So for key value in values.items, come on, help me out here. For key value in value.items. So now we are processing our dictionary. Again, we have to verify the type because it's really all about type validation. So if this is, again, if this is not any and not an instance of the key type, so instance, we are comparing the key and the key type. If this happens, then we have an error. So again, I'm going to print a message to the user, and here I can say again validation command should be a string. What is going on? Again, I can say validation failed. What I can also say is for key, and then I again provide the field name. And maybe I can say something more. I can say key type mismatch for dict, something like this. And again, I'm setting validation error to true, just to so we encountered an error. And what I can also do is to check for the value type. So I can say if value type. If it is not any and not instance of, again, look at the value type. So v for the value and then compare the value type. So if this is the case, again, we have an error. So now I need to print this out again. And again, validation failed for key, and then I provide the key again. So this should also actually be the field name. So for this, and then I can say value mismatch in dict. Sorry, I should say some like in dictionary here to make it more fitting to what we are doing. And of course, again, our validation error becomes zero. Becomes true again. So, but what we can actually do at this point is to maybe down here before we return to see if validation error, if we have any error. Now we can simply return false to show that the validation failed, and we return none for the object. Okay, let's continue. I'm just going to close the terminal so we can have more room to work. So on that subscripted generics, the next thing I would want to look at would be a list. And I'm not going to probably not be able to do everything, but I'll do the basics and leave the rest for you. So look at when the type is a list. So I create a new variable item type. Again, this is going to come from the args. And I'm going to just take the first one because that's more or less what's interesting for us. Again, we check the instance. So we say if instance, and we compare the value and a list. So it has to be a list, but if that's not the case, again, we print our error, and we can say validation failed. And I say validation failed for key, field name. And what we can also add, maybe say expected a list got. Again, I need to provide the type of what we actually got, and that will be the type of value. Again, I'm going to set validation error to true. But if that's not the case, I would like to loop through all the items in value. So I'll say for item in value. In this case, our value is of course a list. And again, I need to compare the types. So again, if it is not any, because again, we want to consider also when it is also a generic. So if it's not any, and of course we compare the instance with the item type. So I say item, and the type has to be item type. When this is not the case, again we have an error. Again, if you can see how we're going here, we are only actually interested in finding errors, which is really the point of validation. So again, we say validation failed for key. Again, field name, and we add additional information, and we say maybe again save list item type mismatch. I don't know, something like this. And again, we set our validation error to true. So that's all I'm probably going to do for subscripted generics. Maybe I add a comment here, sub for subscripted generics. But when that's not the case, I want to consider. So maybe I would like to consider every other basic type. So I can say else. Again, maybe I add a comment, validate other basic types. Come on. So what we simply do here is, this is pretty straightforward. You just check the instance. So value against field type. So if it is a string, for example, we simply check the instance of that, more or less. So again, if that happens, if we don't find what we expect, again, we say validation field for key. Again, we'll provide the key. Again, this is going to be field name. Again, we add additional information. I'll say expected field type. But we got, again, we'll get the type of value. Basically like this. And then, again, we return our error. So this is for all other types. And maybe we can actually just try to see if we can use this with what we have right now. So let me open the terminal and let's test. And we have some error. Okay, I think I figured out what the error is. So here, this should have just been a key and not adding this as a dictionary. So okay, let's try that one more time. And now we get what we expected. So validation fed for key phone number, we are expecting an int, but we got a string. And that's actually happening down here because we are basically validating, like we said, basic types. Okay, so so if we more or less this should work for the most cases. For example, if we have another field in here, I don't know, like and I say extra. So this extra is going to be of type dict. It's going to be a dictionary. And then in here, we can now actually add this here. So say extra. And it's going to be a dictionary again. So the content maybe would be, say, I don't know, remote, true. And then we try to validate this and we got an error. Let's see. Okay, so we have an error because also that's, I think, quite evident here, not enough argument values to unpack. And that's also because we need to give more value here. So of course we need to say like, we need to provide the key and then of course the value. So I'm gonna say maybe extra is gonna be, the key is gonna be string and the value is gonna be bool. So let's see what happens. And that actually goes to actually the error we are now getting is for this one. So I'm just going to take it back to an int. And now our validation should pass. And now let's see what happens when we make this a string maybe. And see, now we also get the error validation fed for key extra value mismatch indexed. So that's really what we want to do. And it's of course behaving the way we would expect it to. Okay, so what if we want to have a union? So what if phone number, we want phone number to be a union between an int and a float. So we want to be able to pass an int and a float. If we run this now, it's just really going to go through because we have to explicitly handle this. And if we don't, then it's not going to be validated at all. And again, that's actually pretty straightforward for us to handle. So I'm just going to come in here after validating for our subscripted generics. I can now come in here and we check for when origin is a union. So I'll say if origin is union. And now what we need to do is actually pretty straightforward. We only need to check the instance of the arguments within our union. So I can say if not is instance, I'll try to maybe do this, use the any keyword because now we have more than one argument to look through. So I'll use the any function. And now in it, I'll have to, of course, provide the arguments, the argument types I'm trying to validate. Okay, so again, I use the instance function. And then within it, of course, I pass the value and also pass arg type. And of course, archetype is going to come from looping through all the arguments in our union. So I say for archetype, and we look through our args. Okay, so if this is not the case again, we can simply again just like we did before, say validation error, and we provide, or maybe I simply just like we did say validation failed for key. Again, I provide the field type. Sorry, I provide the field name. So validation failed for field name. And now I can again add more info and I can say expected one of, okay, I'm looking at the args, expected one of these args, but then I got type. I need to provide the type of what I got, so I'll provide the type of value. Okay, and again, what happened? Yes, and of course let me copy this one more time to set the validation error to true. And now we can try to validate this, and we get, let me see, or is a continuation, so I need to change this to else if. So I'm gonna just make it else if, so it doesn't, of course, skip that. So let's see. And now this should of course go true. So now what it means is that if we now change this back to a string, for example, and actually I made a mistake, so we should have actually considered this under our subscripted generics, and maybe also even change this to some like this, if, and then we can handle all of this under this. Now we can actually try this out, and we get the error, of course, that it failed because now we are getting here. And the reason is, of course, quite simple. Now our phone number should be an int, either an int or a float, but we pass a string. That's also what we get here. So it's expected it to be either of class int or float, but we got a string. And that's really one cool way of doing it. And of course, if we have a recursive type, for example, where let's say we have inheritance, and we should also be able to handle those scenarios. So what I can also maybe do down here is to consider one of those scenarios whereby what we have is an instance of the base class. So I can say if we look at this instance, and now of course we consider the field type, and of course the arg type. I'm sorry, we just look at the type. And of course, if it is a subclass of our base class, so again, field type, and our base class, which happens to be called base model. So if this is the case, now we should be able to handle this. And all we have to do basically is to more or less call this in a nested kind of way. But there are two things I would like us to do. So we want to consider nested base model. And when I say nested, I mean something like this. So if we have here another attribute called props, and we have a class called props, we can also have that class come up here, say data class, and the class will be called props, and then it also inherits from the base model. And maybe just one attribute, I can say prop1 will be a string. If this happens to be the case, this is what I mean by like nested kind of inheritance. That's what I'm trying to consider here. So if that's the case, and what I simply need to do again, we'll just check the instance. So if not is instance, and what I'm considering here, of course, will be the value. And let me say if it is a dict, or rather if it is not, and I can say, of course, validation has failed again. Validation failed for key, and then I provide the field name. And I can say must be a dictionary, something like this. And because of course it has to be a dictionary, in our own case, it has to be an object basically. So again, our validation error is true. But if this is not the case, again, we simply need to do, as you can already imagine, is to recursively call itself. And then this would of course come from field type. Again, we call the validate method, and then we simply pass the value. And again, we handle this. I say if not valid, if this fails. So again, it has to be it's valid. If this is the case, again, we print something to the user, and we say, of course, I have to add a colon here. Again, we say validation failed for nested field. Again, I'll pass the field name as simple as this, and again, set our validation error to true. So that's actually, I think it's actually pretty straightforward, and something I will of course encourage you to try out. But as you can see, most of this to do some of these tasks are actually not quite that hard if you really understand the hang of it, and you would more or less begin to appreciate at least the work that people put into write some of these libraries that you use every day without even giving it a second thought. So guys, that's one quick way of doing it. There are of course probably much more better ways you could do it, but again, the underlying concept, the underlying logic remains the same. So you are only interested about types that do not match what they are expected to match. But anyways, guys, that would be all. I expect you to, of course, to go ahead and implement most of all the other options we could have. Okay, here you could maybe consider scenarios whereby here could be optional string, where it could be a string or none. So I also expect you to can also easily handle that in here, and some of the other types as well. And again, feel free to play around with it and let me know. Reach out to me, of course, if you have questions or if something is not quite clear to you. Anyways, guys, that will be all for now. And yeah, we'll draw the curtains here, and until see each other again, stay learning and have a lovely evening. Bye bye.